We are live. We are live. Isn't this cool? Everybody say hello.
Hello.
Oh, you've been videotaped. That's awesome. Okay, so adding and subtracting fractions. Fractions are, for some people, are the scariest things on the planet. And they're really not. You know, you just have to get in your brain how they work. And I just, like I said last week, I always think of a pie, right? If I'm dealing with two fractions I'm adding together, I have to have the denominator is going to be the number of pieces. 1, 2. So I have, whoops. You got the idea right? Shoot, you know I do that. I always do this kind of thing on the video. That's great. Okay, so I have 8 equal pieces, right? So my denominator is going to be 8. And then the number of pieces Gary alone eats at one sitting is going to be 6/8, right? I'm going to eat 6 of these. 1, 2, 3, 4, 5, 6. So I ate 6/8 of those, right? And then Mara came along right before I was going to eat the last 2. And she ate the other 2 pieces. So I had 6 of the 8 pieces. She had 2 of the 8 pieces. So together we ate 8 out of the 8 pieces, which meant we ate one pie, one whole pie, right? So fractions are ways to just talk about less than a pie, right? I didn't have quite enough room in me to have 8/8 of the pie, which would have been the whole pie, right? So I just had just enough room to have 6/8 of the pie. Doggone, Mara. Don't ever do that again, okay? I was saving those 2 pieces for myself. Okay, so, but the important thing is, in order to add fractions together, or subtract fractions from each other, you have to have the pies cut in the same number of pieces, right? Otherwise it doesn't work. Every piece has to be identical in size, okay? Identical in size. I contemplated bringing in 2 pumpkin pies and cutting them up, and I thought, oh, I don't know, maybe somebody's allergic to something. I said, no, it's not worth it. But anyways, so the first thing, the first rule, or the only rule, basically is, you must have common denominators. Okay? You must have common denominators. That basically means your pieces have to all be the same size. You have to have the same number in the denominator, right? The same number of pieces, right? Yes?
I was wondering if it would be a good idea if, like, in the back of our books, we made an index of, like, rules and,
that's a great idea.
formulas and stuff like that, so if we ever need it, would that be cool?
That's a great idea, yeah. And then, like, sometimes, too, after, like, a week or so, you know, you might want to create an index to what's in your notes, because I might be jumping around a little bit, and then you see something, you get a homework that has some review in it, you realize, oh, that's absolute values. How do I deal with absolute values? So you can quickly go to your index, and if you do it on the computer, you know, there are ways to have it quickly sort. Like if you do it in Excel, I don't know if you guys, how many people know what Excel is? A few of you? If you do it in Excel, you can have it quickly sort it by alphabetical order, so that you can always have an index that is in alphabetical order. Is really helpful. But we can talk about that as it goes along. Are you guys going to cover that kind of stuff in computer class, Nate? Oh, I'm sorry. Like sorting, like if they wanted to do a table of contents or an index, you know, where they could say absolute values and systems of equations and whatever, and they're not in alphabetical order. If they did it in Excel, it'd be really quick and easy to sort it. Maybe you can do that in Word too, I'm not sure. Can you? I've always done it in Excel.
Yeah.
But you can sort by alphabetical order, and it makes it really, really easy. Then you can look things up really fast. And you can just periodically take the old one out and paste a new one in and print it out. Anyways, just thought, I just wondered. All right, so there are 3 types of fractions we're going to cover. I mean, adding or subtracting fractions today that we're going to cover. The first is where they already have common denominators, okay? So this is the first, this is the first one, okay? Already have common denominators. Already have common denom. Can I just do that? Okay. Already have common denominators. So A, our first one, A. We have 2/9 plus 5/9 equals. And I think you all know this because it's pretty obvious. But when I'm adding or subtracting, the denominator has to be the common denominator. Go ahead, 7.
Is it 7/9?
It is 7/9, exactly. So you keep the denominator, the common denominator in the denominator, and then you just add the number of pieces that I ate, right? I ate 2 pieces of the 9, and then I ate 5 more of the 9 pieces. So I ate total of 7 of the 9 pieces. Does that make sense? Does that make sense? So it's pretty straightforward. Okay, B. So these we're not going to spend a whole lot of time on because they're so simple. You just add the numerators, right? So 4/15 plus, I don't know, 8/15 equals, okay, listen,
12/15.
12. So you added 8 plus 4, so that's 12/15. All right? Now, sometimes when you have an answer, well, actually all times when you have an answer, you always want to look at the answer and ask yourself, did I write this in simplest form? And with fractions, you have to ask yourself, is there a number, one number, that goes into both these numbers, top and bottom? So, Graham.
Wouldn't it be 3/10? No. No. 4/5.
Well, what's the number? 4. Okay. So what's the number that you divided that you noticed that both go into?
4.
4. I mean 3. You said 3. 3 goes into both of these, right? So you're saying that if you divided this by 3 and this by 3, it has to be the same number, top and bottom, right? Then 12 divided by 3 is 4, and 15 divided by 3 is 5, right? So you're right, 4/5. Perfect. Good job. Excellent. What about this one? Can we simplify that one?
No.
There's no number other than 1 that goes into both of these. And so if I divided this by 1, it wouldn't help. 7 divided by 1 is 7. 9 divided by 1 is 9. So I'd still have 7/9. But here, it worked. All right? So one last one. A, B, C. 6 twelfths plus 3 twelfths equals 80. 9 twelfths, right? So we just add the 6 and the 3, keep the 12 in the bottom. All right, so somebody else. Okay, yeah, Becca, what would you do? Divide. Okay, so you're asking yourself what number goes into both of these, right? So 3 goes into both of these, right? So we're going to divide by 3, divide by 3. Got to do it to both top and bottom. So what does that give you? 9 divided by 3 is 3. 12 divided by 3 is 4. There we go. Beautiful. All right, so that's called reducing or simplifying your fraction, right? Now, my guess, fist to 5. Are you guys getting this? So far, it's fairly straightforward, right?
Yes.
So far. Okay, good. Awesome. Okay. So now we're gonna, can I erase this?
Yeah.
Is everybody done? Okay, cool. Now we're going to, okay. It's the next ones that are, the next 2 that we're going to spend most of the time on. Because I want you to really get used to this. So number 2. The second type of problem are where, let's see here, let me think about this. Okay, so the second type of problem we're going to do is where you only have to multiply one fraction. There's going to be two fractions, but you only have to multiply one of them times something in order to get the common denominator. Okay, so something like this. So A, 2 fifths plus 3 tenths. 2 fifths plus 3 tenths. So the question I'm always asking myself, I say, okay, do they have common denominators? No, they don't. One's a 5 and one's a 10. So then my next question is, can I turn the smaller number into the bigger number? What would I have to do to 5? What would I multiply it by? 2. So watch this. I'm going to put parentheses here and a fraction line. 5 times 2, and then what is going to be 10. So whatever I put down here, I also put up here. And what does 2 over 2 equal? 2 over 2 equals 1. So I'm multiplying 2 fifths times 1, right? And anything times 1 is itself, right? But with fractions, it's going to look different. Because I'm multiplying it times a weird one. It's a 2 over 2 instead of 1, right? So I multiply, when you multiply fractions, you multiply the numerators, and then you multiply the denominators. So 2 times 2 is 4, over 2 times 5 is 10, plus 3 tenths. Oh, wow. Now we're back to the first kind, the easy kind. Now we have our common denominators. So what's the answer? Violet. What is it?
7.
Yes, you're right. 7 tenths. So 4 plus 3 is 7. 7 tenths. All right. Now B. Let's see. I'm going to do B here, I guess. B. How's the temperature in here? Is it hot or cold or?
It's fine.
It's okay. Okay. If it ever isn't, let me know. Okay. All right. So let's say we do 4 sixths plus, or let's see, minus. We'll do minus this time. Minus 1/12. All right. Again, the question I ask is, do we have, we're adding or subtracting. In this case, we're subtracting. Do I have common denominators?
Yes.
No.
Oh, wait,
But then the next question I ask is, can I turn the littler denominator into the bigger by multiplying it times something? In this case, yeah, if I multiply it times 2. Okay, so now, same thing again. I'm going to put my parentheses. 6 times what is 12? 6 times 2. Whatever I put in the bottom, I have to put in the top, so that I'm multiplying times the value of 1. So I'm not changing the value, I'm just changing the way it looks. So suddenly 2 times 4 is 8. 2 times 6 is 12. Minus 1/12. And what's my answer? Somebody different. Abby.
7/12.
Right, so we got 8/12. Somebody took 1/12 away from the 8/12. They have 7/12, right? 7/12. All right, C. We'll just C up here.
Wait, then
All right, hang on. How about 2/3 minus 15 24ths. So I'm going to look at this and I'm thinking, what? You can't do that. This is way bigger. This is 15 24ths. This is only 2/3. Right? I can't do that. Well, actually, I got to go back to my questions again. Do they have common denominators? No. Okay, my second question. Can I turn the littler number into the bigger number by multiplying it times something? All right, Diego, what? 3 times what is 24?
8.
Yes, perfect. So I'm going to draw my parentheses, put my line there. 3 times 8 is 24, and that means I'm going to put an 8 up here as well. So 8 over 8 is 1, so I'm multiplying 2/3 times a weird 1, right? So 8 times 2 is 16. 8 times 3 is 24. Minus 15 24ths. And so what's the answer, Weston?
1/24.
So the answer is 1/24. So the key with fractions is you can't know how two fractions relate to each other until they have common denominators. You don't know which one's bigger and which one's littler until you get common denominators. Oftentimes that's a question on an SAT problem that's very common, where they'll give you two fractions and they'll say, which one's bigger? I don't know, like 7/8 doesn't sound as big as, 22 33ths, right? But it turns out 7/8 is bigger, right? But, it's like you kind of have to get common denominators before you can tell which one is which. But anyways, fist to 5 on this one. I'm just curious. Fist to 5. Fist to 5. All right. Let me give you a couple to do on your paper, right? In your notes, without me doing it. I'll set it up and then I'll put it up here, and then I want to see if you can do it. All right, so A, B, C, D. So, all right, everybody try D. Think of those two questions that I asked. I'm going to write out the questions. That's not how I worded it first. That was good. Hold on. You got the idea. You can reword that if you want. Say what?
Questions, just my notes. Yes.
Say what?
Questions.
Yeah. Well, if you want to. If you know them already, then it's okay. But if you know.
Was that the only? Yeah.
Okay. So we'll do another one too. So D, E, let me think here. Let's do minus. Sorry. Let me think. So, how many people got 21 over 20 or 1 and 1/20th for the first one? Awesome. Awesome. Yes. Doing great. Proud of you. All right. The second one, how many people got 24/72s? Okay, awesome. Now, can that one be simplified though?
I reduced it to 1.
How would you know? Yeah.
8 goes into both.
8 goes into both of them? Great.
Well,
Look at that. So we could, so 8 times, so we're going to divide this by 8 and divide this by 8, right? And so that's going to give us 24 divided by 8 is 3. 72 divided by 8 is 9. Oh!
3 minutes.
But 3 goes into both of them, yes.
Well,
Victoria.
I put 12. Because 72 is a 12.
Yeah, you're right. You're right.
So
So yeah, so we're going to keep going. So divide by 3, divide by 3. So we got 1/3. Is that what you got?
Yeah, I got
Yeah, okay. So good. So, do you see how to do that, Violet? Does that make sense to you? You're just looking for a number that goes into both of them, top and bottom, right? Okay? All right, fist of 5 on the number 2 times. Fist of 5. Fist of 5. 5 means I totally get it, right? It's like so easy for me. 0 means I don't get it at all. 1 means I don't get it very well. 4 means I'm doing pretty good, but like, I could probably use a little practice. Okay, everybody. So you don't have to go like this. You can just, if you don't want to show everybody, you can just put it in front of your chest, whatever. So just so I know kind of where people are at. All right. So do you all get the idea of asking those 2 questions? That first question, do they have common denominators? If they don't, can I turn the smaller one, the smaller denominator, into the bigger? I'd actually rather write it that way, but it doesn't matter. You got the idea. So now let's go to the third type. Multiply. I'll leave that up there for a second. Okay, so the third type. Only this time it says multiply both fractions to get the common denominator. This is the one that's the hardest, but it's not that hard. If you get the other one, this is not much harder. It's just one extra thing. All right, so let's say I gave you, so A, say I gave you 1/3 plus 2/4. So I start again with my questions. I see, well, I'm adding fractions together. So I start with the same questions. Do they have common denominators? No, they don't. They do not have common denominators. So I keep going. The next question, can I turn the smaller number into the bigger by multiplying it times something? That's how I should have worded that. Can I turn the smaller number into the bigger? No, not really. I mean, I probably could figure something out, but I don't want to make it hard on myself. That's just too hard. You know, I'd have to use decimals or fractions, right? Fractions of fractions of fractions of fractions times fractions equals fractions galore, right? I don't want to do that. So I can't turn the 3 into the 4 easily. I can't do that. What would you do?
But you can turn them both into 12.
Yes. So you ask yourself, the third question you'd ask yourself,
Trying to find the lowest common denominator.
thank you. What is the lowest common denominator? So, what is it? You said 12, right? So, this is what I do. So, I know now I'm going to have to change, I'm going to have to multiply both of these equations by something. So, I know my common denominator is 12. That's my goal. I have to get to 12. So, I do my little parentheses and my line, parentheses and my line, and I ask 3 times what is equal to 12? 3 times 4. So, boom. And I put a 4 up here. Whatever I put here, I have to put here. And then I go over here. I say 4 times what equals 12? 3, right? So I put a 3 here. Whatever I put here, I have to put here. So I have to put a 3 here. So I'm always multiplying each fraction by the value of 1. So I'm not changing its value. I'm just changing the way it's going to look. So now I have 4 times 1 is 4 over 4 times 3 is 12. And then I say plus. And then I have 2 times 3 is 6 over 4 times 3 is 12. Yes! Now I have common denominators. Now it's like those first ones that you guys all told me you had 5s. You had a fist of 5, you gave me 5s, right? Everybody knows how to do this. There's 4, I ate 4 of the 12 pieces of the pie. And then later, I came back and I had 6 pieces of the 12 pie. So how much pie did I eat? 10 twelfths of the pie.
Which also equals 5/6.
Yeah, because exactly. Notice how they're both even. Do you know what evens are in odds? You guys all learned that? Like 2, 4, 6, 8 is evens. 1, 3, 5, 7 are odds, right? So if they're evens, they're always divisible by 2. So that's, if you have a horrible fraction like 274 divided, over, 892, if they're both even, you know you can at least divide by 2.
Isn't it like if the last number is an even number, then the whole number is even?
Yes, exactly. So we know that these are both even, so we're going to divide the top and the bottom by 2, right? It's like a plus. That's what it's like. Okay, so we have 5, and then 12 divided by 2 is 6. So that's our answer. All right, so B. What did I do, 3 and 4? Okay. Okay, how about 2/5 plus 3/6? So, they look so close together, I'm just going to do that. So, I ask my questions. Do they have common denominators? No. All right, then I ask myself, can I turn the smaller denominator into the bigger denominator easily? No. 5 times, there's no easy way to get that. So then my third question is, what is the lowest common denominator? I can always just multiply 5 times 6. That might be it. 5 times 6 is 30. Because I know 30, both of these numbers go into 30 because I used those numbers to get 30, right? 5 times 6 is 30. And is that it? That's probably my lowest common denominator in this case, right? Yeah. That's it. So immediately I will boom, 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 boom. 5 times what is 30? 5 times 6. And then I got to put a 6 up here. 6 times what? 6 times 5, put a 5 up here. Right? You with me? You guys all get this?
Yes.
And I know some of you guys are probably really good at this. And I'm aware of that. I'm aware of that. I just want, it's really important that we as a class come together, right? And so wherever we need to learn stuff, we're going to do that so that we can come together and we can move forward. Because I will be giving you problems, algebraic problems with fractions in it. And I will have to teach you I will teach you some amazing tricks to turn a horrible looking problem into, in one move, the easiest thing you could imagine. Just one move, you can take this horrible fraction problem and solve for x, and no problem. All right, so anyways, 6 times 2, my numerator, 6 times 2 is 12, over 30 plus 3 times 5 is 15, over 30, and that gives me 27, right? Over 30, and that's I'm probably done, right?
No,
9
3.
tenths.
3 can go into 9.
What is it? 9 tenths? What did you said by 3? 3 times 9 is 27. 3 times 10 is 30. So we're going to divide by 3. Divide by 3. So we get 27 by 3 is 9. 30 by 3 is 10. 9 tenths. Very good. Excellent. All right. Notice how these take a little more room, right? It's like a little more space. You got to allow for that. All right, where are we? Should we do one more?
Yeah,
Do
sure.
you want me to do one more?
Yeah.
Okay, one more, and then I'm going to hand out the homeworks. Can I erase this?
Yes.
Okay. All right. So last one, C. Seven eighths minus 3 ninths. So again, I asked myself, do they have common denominators? No. Can I turn the smaller denominator into the bigger denominator easily? No. So what is the lowest common denominator? And it doesn't always have to be the lowest. It can be a common denominator. It doesn't matter. You can do 8 times 9. You know. There may be something else, but to be honest with you, I don't know right off the top of my head, so I'm just going to do 8, 9 and 9, and 8 and 8. Oh, that's me. Oh, that's me. Who's got their phone on? It's me. That's to remind me that we have to do axe time. Don't let me forget. So keep going. 9 times 7 is?
63.
Yes, okay, 63. All over. 9 times 8 is?
72.
We already did that one, right? Okay, 3 times 8 is?
24.
24. 9 times 8 is 72. Now we have common denominators. Perfect, so it's easy, but it's a minus, right? So it's 63 minus 24. I might have to just do this over here because I can't do that in my head so well. Because I'm going to have to borrow, right? I'm going to have to turn this into a 5, make this 13. 4 from 13 is 9. 2 from 5 is 3. So that would give me 39 72s. Is that what you guys all got? And is there a way to simplify that? Yeah?
For some reason, it doesn't make it both be divided by 3, because 39 is
Good point. 3 goes into 3 once, and 3 goes into 9 3 times. And I know if 3 goes into 12, right? You guys all know that? And 12 goes into 72. So 3's got to go into both of these. So I'm going to divide by 3, divide by 3. So 3 into 3 is 1, 3 into 9 is 3. 3 into 7 is 2, right? And there's 1, that makes 6. 2 times 3 is 6. There's 1 left over to get the 7, so I'm going to put this 1 in front of the 2 to make 12. 3 into 12 is 4. So 13, 24, so that's what you guys got? Does that make sense? Fist to 5. Awesome. Awesome. Okay. All right, I'm going to pass out the homework. And there are 3 different scenarios. Some of them will go really fast. Some of them will take a little longer. 1, 2, 3. Oh, shoot. I turned that computer off. I gotta stop thinking of. I always do this.